Yo, welcome back. Um, welcome back. Let me fix the speaker. Okay, so today we're doing adding the angles in a triangle, and it's about exploring angles in a triangle. All right, so let's get it started. All right, it says complete the table by drawing a triangle in each cell that represents the properties listed for each column and row. If you think you can draw a triangle with those properties, write impossible in the cell. Okay, share your drawings with your partner, discuss your thinking. If you disagree, work to reach an agreement. Okay, so this is assuming that you already know what these triangles are. So I don't know. I guess you're supposed to know that from last year. All right. So what I'm going to do, let me take a look at this, is just give you, remind you what these are in case you don't know. So acute is less than 3 angles that are less than 90. 3 angles, okay, 3 angles less than 90 degrees. I'm trying to make your notes as brief as possible. Right has one. Let me see if I can put 190 degree angle. Okay, obtuse as 1 greater than 90 degree angle, and we're obviously talking about angles. Scalene has no equal sides. Has no equal sides. Isosceles has 2 equal sides. Has 2 equal sides. And equilateral has 3 equal sides. Has 3 equal sides. All right, so with your partner, you're supposed to draw a triangle that represents. So right here, you're going to draw an acute angle that is also scalene at the same time. Okay, and then this is a right angle that has no equal sides. So yeah, work on that with your partner. Take a minute and try to predict what the answers are. Maybe you do it on the side here, okay, so that you can, or maybe you draw a line, okay, and draw like a small example, or I guess you could kind of split it in half, so you could put your prediction on top, and then when we go over it, put that at the bottom. Use your best judgment. Okay, if you need rulers and protractors and whatever you need, make sure you get those items. So take a moment to get that, and we'll be back to follow up on that. Alright, so let's keep this moving. Scalene and acute. Alright, so what's scalene? That means has no equal sides, or all the sides are different. Okay, so basically it's going to be, it's kind of hard to do these things. That looks equilateral. All right, so let's say like this. you know, this is going to be a little tricky to do. I mean, to demonstrate. But say this is this length, this is this length. Okay, so put two little lines here, and I put three lines here to indicate that each of these is a different length, and they're all less than 90. So something like that. And what do we got here? Scalene and right. Okay, so basically that could be something like, well, first of all, you got a right angle with a long side and a right angle with a short side. Boom. And then you got a side, or an extra long side. Okay, so then you could go in here, and so this is one. Come on now, let me get 1, 2, and then 3. Okay, something like that. Okay, and then obtuse and scalene is going to look something like same thing. You got like a short side, a longer side that is greater than 90. Okay, that's a long side, and then this is a longer side. Okay, so say this is one length, this is 2 lengths, and then this is the longest side at 3 lengths. All right, then we got isosceles acute. Okay, isosceles acute. So that's less than 90, and it has 2 equal sides. All right, so that's going to be 2 equal sides, 2 equal sides, and then something like that. Okay, assuming those sides are connected. All right, so these are the same. These are the same, and then this is a different length. All right, and then we got isosceles right. It's kind of the same thing. So say we got a right angle here and a right angle here. Let's assume these are the same length. And then you got, well, let's not do that. Then we're going to connect them with a long side like that. That is a different length. Okay, so these are, okay, 2, 2, and then this is a long side of 3, and this is a right triangle. All right, and then obtuse and isosceles. All right, so we start with a obtuse angle, and then we're going to have this one. All right, so we got 1, 2, 1, 2, and this is 1. Whoa. 1, 2, 3. All right, equilateral acute. So we got less 3 sides, all the same. All right, so let's say this is 1, 2, 3, and all of these are the same length. All right, so we could just say 1, we could say 1, and we could say 1, because they're all the same length. Now you can't have a, this is going to be not possible. Not possible. Obtuse angle with 3 sides equal length. That's going to be not possible. All right, so that's how you do that. Go ahead and put that in your notes, and then we're going to move on to the next section. Alright, assuming that's in your notes. I think we can zoom this up here. See what they're talking about. Alright, so the next thing we got here, it says your teacher will give you a card with a picture of a triangle. The measurement of the triangles is labeled. Mentally estimate the measures of the other two angles. Find two students with triangles congruent to yours but with a different angle labeled. Confirm that the triangles are congruent, that each card has a different angle labeled, and that the angle measurements make sense. Enter the three angle measurements of your triangle on the table your teacher has posted. Okay, so I don't know if we're going to do that activity, but these are all the angles that are supposed to get cut up and passed around the room. So let's just, take a look at that. Okay, so ideally you would go around the room and find the three people would find each other, okay, that have these three angles. Okay, and then you all would deduce, oh, okay, your angle's the same as mine, so these three are all the same, and this one is 90, and then you would say, oh, okay, so this one must be 40. Okay, this one says 90, this one says 90, so the three of you all would have to meet up and then put your three angles together and find out the missing sides. Okay, and then you all would deduce that all of them together, angles together, equal 180. Okay, and that would be the same for all of these groups of three. Okay, so you would have 120 plus 20 plus 40. So that would these would all be 180 with a 40 and a 20. Okay, so to save time, we're not going to really do that activity, but it basically is to get you all to understand through this collaboration that triangles are made up of three angles that all together are 180. So a triangle is made up of three angles that the sum of the three angles is 180. All right, so we probably not going to do that. All right, that was the activity. Delete. Okay, tear it up. Your teacher will give you a page with three sets of angles and blank space. Cut out each of the three angles. Can you make a triangle from each set that has the same three angles? Now, I probably have a piece of paper with this on one side just for you to look at, and then this would be on the other side. And then you all could try to do this activity with a pair of scissors. So basically you would cut up, pick one of these groups of three angles, and then the idea of this activity is to basically make a triangle by cutting out the paper, and you would take, say this is triangle 1, and this, that's not a good drawing. Let me try that one more time. Let's do it like this. Alright, so we got triangle 1, triangle 2, triangle 3. Okay, so you would cut these out and say this is cut all into pieces or whatever, and then you would try to make one angle triangle 1, one angle triangle 2, and one triangle 3. So you would cut this out and try to reshape these angles into one cohesive triangle. All right, so that activity I think we can pull off. So and you all can work on groups to do that, and you can just choose whichever of these angles are on this paper you want to work with, or you can try more than one. All right, so go ahead and take time to work on that activity now. All right. All right, so for the next activity, basically it says a quadrilateral. So that's a shape with four sides. So say you just use a scrap of paper from the last activity. All right, so what you're gonna do is take and cut a four-sided shape. So say it could be like this, something like let's say something like this, just four-sided. A quadrilateral is a four-sided shape. Boom. Okay, cut it, tear off its angle, and then line them up. What do you notice? So basically what you're going to do is um, put, say, angle 1, and then angle 2, and then angle 3, and then angle 4. Okay, and then you're going to rip off these angles, and it doesn't have to be pretty. Okay, it doesn't have to be pretty. So what you're going to find, you're going to try to arrange them and connect the angles. So what I'm trying to say is, say angle 1. I don't know how I'm gonna do that. Okay, I'll just do the best. Okay, say angle 1 is looking something like this when you tore it off. Okay, it's more like this. Okay, so say that's angle 1 and it's jagged because you ripped it off. Okay, and then next you're going to take angle 2, which is, I don't know, it's going to look something like this. Not a good look. Let's try it again. It's going to look something like this. Okay, but it's going to be jagged because you ripped the corner off. Okay, and then what you're going to do is take rip 3 off, and then try to align that with the rest of the group here. So say that's going to look like, boom, boom. That's going to look like, it's kind of an obtuse angle. It's going to look something like that. Okay, it's going to look something like that because this is a kind of an obtuse angle here. So it's going to be ripped off. Okay, so this would be our angle. I don't know. Would it look like that? Whoa. Boom. Okay. I don't know if it'll be pointed like this. I'm just drawing it as a simulation. This would be our angle 2, and this over here would be our angle 3. And guess what? This is gonna, when you rip this off and stick that in there, guess what you're gonna end up with? Ta-da, you're gonna end up with a 360 degree angle. So go ahead and hope I didn't mess up the surprise for you, but you still got to go through and do it yourself. Try to do it for 2 angles like each of your partners. Okay, so try to be creative and create a, with your rulers, a 4-angle shape, a four-sided quadrilateral. Obviously that would be the easiest one. Okay, that's a quadrilateral, but go ahead and challenge yourself and try to make some abstract four-sided shapes and see what you come up with. So go ahead, take some time to do that, and then we'll come back. All right, so you had some time to do that activity, so we're off to the next. It'd be cool if you can kind of trace your triangle in the book and have some type of evidence of notation of what you did in class. Okay, so take some time to do that. All right, assuming that's done, let's move on to the next thing. Next thing is the summary. Okay, next thing is the summary. It says 180-degree angle is called straight angle because it's made up of two rays. They point in opposite direction and form a straight line. If we experiment with the angles in a triangle, we find that the sum of the measures of the three triangles in each triangle is 180 degrees, the same as the straight angle. Okay. Through experimentation, we find if we add the three angles to a triangle physically by cutting them off and lining them up, the vertices and sides, then the three angles form a straight triangle. Okay, if we have a line and two rays that form three angles added to make a straight angle, then there is a triangle with these three angles. Okay, and we also did it with a quadrilateral. Okay, and we found out that a quadrilateral equals 360 degrees. So a triangle is 180, quadrilateral is 360. That makes sense because basically a quadrilateral is two triangles. If you cut it in half, you're going to get two triangles. So if one triangle is 180, it makes sense that two triangles would be 360. Okay. All right. So that's it for that lessons. If you got any questions, ask me in class other than that. Peace.